Good morning, class. Today we're going to dive into a fundamental topic in physics, kinematics. Kinematics is all about describing motion, but without worrying about the causes behind that motion. Imagine you're a detective trying to figure out how fast something moved or how far it went, based on the clues you have. First, let's recall a few things: speed, velocity, and acceleration. We use these to describe how something moves. But kinematics gets interesting when we start dealing with different types of motion, especially with constant acceleration. Let's focus on 4 key equations that help us solve most motion problems. Equation 1. Velocity-time relationship. The first equation tells us how an object's velocity changes over time if the acceleration is constant. It's given by v equals u plus at. Here, v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time. For example, if a car starts at 5 meters per second and accelerates at 2 meters per second squared for 3 seconds, we can find its final velocity. The second equation helps us find the distance or displacement traveled by an object. It's given by s equals ut plus 1/2 at squared. Here, s represents the displacement, or how far the object has moved. The initial velocity u and the time t are multiplied, and we add half of the acceleration times the square of time. Think of this equation as a way to figure out how far you traveled when starting with a certain speed and speeding up. The third equation connects an object's initial and final velocities with the distance it travels. It's given by v squared equals u squared plus 2a's. This one is great when you don't have the time information but need to find the velocity or distance. For example, if a ball rolls down a hill with an initial velocity of 0 meters per second and accelerates at 3 meters per second squared over 10 meters, you can find out how fast it's going at the end. The last equation is simple but handy when the acceleration is constant. It helps you find the average velocity over a certain time period. S equals 1/2 of u plus v times t. This one works when you know both the initial and final velocities and want to find the total distance traveled. It's like finding the average speed for a whole trip. So these are the 4 basic kinematic equations. They might seem overwhelming at first, but the trick is to understand which equation to use in different situations. Remember, equation 1 helps you find velocity when you have time and acceleration. Equation 2 finds distance when you have initial velocity, time, and acceleration. Equation 3 relates velocities and distance without needing time. Equation 4 finds distance using average velocity. Now imagine you're analyzing a car's motion in a video. With these equations, you can predict how far it will go or how fast it'll be going at different points. Next class, we'll practice with some real-world problems and try to become kinematics experts.